Ooh, all right. Week 9. Here we go. Just a little bit left, and hope you guys are doing well. So, in today's lecture, I wanted to cover just some nice little features in Python. We call this Pythonic features, I guess. So these are things that Python didn't have to include, but it has included them, and it makes things easier. So there is a class called the named tuple. And so we've seen object-oriented programming, and we defined some stuff, so we defined this class point, and we used it to kind of store, an X coordinate and a Y coordinate. And then we said, if you want to kind of print things out, you can, have this string representation of the point. And we used it when we wanted to, I think one of our examples, we defined a rectangle class that contained a point and its width and stuff. Well, there's something called the named tuple, and it's just kind of a quick and very easy way to define a new class, and it's useful if really the only thing you need to do with this tuple or with this class is just for it to kind of store values, and it doesn't kind of require its own methods. So instead of defining a point class like this, we can define a new class called, using the named tuple. So we have to import the concept of the named tuple from the collections module. So we'll go ahead and do that. And then once we do that, we can define a point class object using named tuple. All right, so here, basically, I just provide a little list of the names of the values or attributes that it needs to save, okay? So here I'm going to say point is equal to a named tuple where it's going to contain the values X and Y, okay? All right, so here it says point is a point class kind of object, and if we want to define new instances of it, we do it just like if we had a point class defined. So I'm going to say point 1, 2, and this will take in 1 as X and 2 as Y. So again, just a quick, easy way for us to define a new class without having to fully define it. All right. So instead of doing class point, we can just do named tuple, and here we can see how it prints out. It says X is 1, Y is 2. So that's nice and easy. All right, and because it is the instance is a tuple with names and stuff, we can access its attributes using dot notation. So I could say, what is the Y attribute, X attribute or Y attribute of P, and it gives me those values 1 and 2. All right, it is also a tuple, so the order is preserved, and you can subset it using square bracket notation as well. You can say, what is the 0 index object in this tuple? So these things have all kind of been exist here as well. So, if we had tried to do the point class object, and if I tried to index, say, what is in position, index is position 0, this would fail in our kind of own definition of class point, right? And if we wanted to have square bracket 0 work here, what we would have to define? We would have to define the method double under get item, right? Get item is how we extract items out of something in some kind of class that we've defined. But here, we're going to use named tuple, so it inherits kind of all of the methods that come with tuples as well. Okay, so not only just item getting items or slicing or things like that, but it will inherit all of the other kind of tuple items. So one thing is you can do comparison, right? With tuples, you can do comparison. So we can compare 0.1 and 0.2. Is 0.1 greater than 0.2? It's going to compare the first items first, 0 versus 3, before it looks at the 1 and the 4. In here, it's going to say, well, 0 is not greater than 3, so that's false. What happens when you add tuples together? So if I do P1 plus P2, what happens when you add tuples together? So tuples are iterables, so it just kind of concatenates them together. So if you take P1 and P2 and you add them together, it's going to take the 0, 1 and concatenate the 3, 4 onto it. So you get, this longer tuple, 0, 1, 3, 4. Okay. Here is a list of named of points. Okay, points again being named tuples. And so if I say L is P1, P2, P3, we're going to get point 1, 0.2, and 0.3. And then again with that, you can do something like sorted, and it will take those tuples and sort them. Okay, so a lot of kind of nice little features. Now, if you do want to change some of these behaviors, right? So if you don't want it to be, say, act like a tuple. So for example, with the addition stuff, if you want to take one thing and add another thing, kind of like vectors or something, here you can inherit from that named tuple and then modify some of the methods. So for example, here I'm going to create class vector, and I'm going to change the behavior of addition, and I'm going to say, with addition we need a self and an other, and I'm going to say when you take two vectors and add them together, it's going to return a new vector where the x component is self x plus other x, and then the y component is self y plus other y. And so this inherits everything from the named tuple, but it changes the add behavior. So here I'm going to have vector 1, v1 be 0, 1, a vector 0, 1, vector 2 will be 3, 4, and then I could say, add these two things together to create vector 3, and vector 3 will be x is 3 and y is 5. So that works out nicely. And then just like a tuple, you can still subset and things like that. So it still inherits all of kind of the named tuple things, but again, you can also modify the behavior of some of these methods here. So I think that's pretty neat with the named tuple there. All right. Moving along, there is another class, okay, called the counter. Right. So these are all different kind of collections that exist, and there's a whole bunch of kind of interesting things. So Python collections. There's different things here. So we're looking at the named tuple, and we'll look at the counters, but there's also ordered dictionaries, and then I don't know what a default. Okay. Default dictionary, but you can kind of look up all of the other stuff in collections. Just kind of neat little things. Okay, which are handy for a lot of certain use cases here. Okay, so I'm going to go ahead and import the counter, and what counter will do is basically you provide it any kind of iterable, and it will go through and it will just tally everything up for you. Okay, so in R there's a feature called tally, or a function called tally or table, which kind of do similar things, and the counter works kind of similarly here. So here I have a list of just strings: red, green, blue, and then what we can do is we could feed this into basically this. It's not a function. It looks like a function, but it basically this class called counter, and this will go through and it will create a dictionary after kind of tallying everything up. Okay. Well, it's technically it's a counter. It looks like it behaves, similarly to a dictionary, but it has these things, right? So once we have this, we can kind of ask what are the most common things. I can do tally and square bracket, and just say how many times did blue appear or something like that, right? So it kind of creates this dictionary-like object called a counter, and it just goes through, tallies up a whole bunch of stuff. I think it even works for like strings, right? So if I do I'm a little nervous now, but I'm going to just do counter on string here. Yeah, so it goes through and tells you how many times each character appears, and you can do sorted. No. That's just the keys. And then, well, I guess you can push that into dictionary, and then once you have that, you can still can't. All right. Well, anyway. I think the default for counter is to go in order of in descending order. I guess E appears 4 times, so on and so forth. But anyway, so that's counter. It goes through, tallies up how many you have of each of these things. Okay, let me go ahead and give you your first view quiz answer. It's letter C. Letter C is for a first view quiz answer. Okay, we have list comprehensions. List comprehensions allow us to kind of create new lists based on an existing collection or iterable. And basically, we can say, create, you have square brackets to indicate that what you want is going to go inside the list. And we're going to say, expression for value in collection if condition. And this is basically the equivalent of running this kind of loop where we say, start off with an empty list called result. And then, for each value in the collection, if the condition is true, then we will append whatever expression we want to the results. Okay. So basically, if you want to kind of run through some kind of loop through every kind of item or in an iterable, and then run some kind of expression on it, you can do that. So for example, I could say make a list of the squares by saying do x squared for x in range 1 through 11. Okay, and so that will just give us kind of all the squares from 1 through 100, 1, 4, 9, 16, etc. You can also throw this into a NumPy array, and it will do that as well. If you want to add a condition, you can do that as well. So just for, only for the odd numbers, we can do return x squared in our expression for x in range 1 through 11 if x mod 2 is equal to 1, and that will work as well. Okay, so these are so this is just kind of a quick way to produce lists of results. Again, no real difference from running through a loop this way. Okay, I don't think the list comprehension is computationally fast or anything like that, but it does kind of simplify your code writing a little bit and just makes it a little bit more concise, arguably more elegant in that way as well. Okay, it doesn't have to be numeric expressions. You could say, hey, take this list of strings and then make them uppercase if there's more than 2 characters in the string. So in this case, it will drop a and as, and then we've got bat car dove python just in caps and things like that, right? Here you can say like, I want to extract out the digits. So here's a string, and we want to kind of iterate through each kind of character. So for each X for letter in the string, if it's a digit, then we want that. And, as it iterates through a string and it's looking at each character, those are going to be, it's going to be a string. So what we want to do is we want to convert it to integers. And so if it is a digit, we will apply int x to it. All right. And so this will extract out the digits inside this string. So this is a handy way to kind of extract out digits from a string, and these are handy little list comprehensions that you can run. Okay. You can also run over a dictionary, and so again, you can take a dictionary view object. So for example, d.items returns a list, or is basically a list of tuples here. So if I take d.items and I put that inside list, then I'm going to get a list of tuples here. And what we can do is we can create a list of strings. All right. So I'm going to take, kind of the format, %s is for %s. This is using the Python notation here. I can just do .format. Okay, and so here I've got placeholders for placeholder, taking key and value and iterating over all of the items in the dictionary. So for key and value in d.items, as long as that key is not the letter B or D, and it takes, A is for apple, skips over B, C is for carrots, skips over D, E is for eggs, so on and so forth. Okay. So these are list comprehensions, and list comprehensions are handy. Same kind of idea applies to dictionary comprehensions as well. Dictionary comprehensions, you basically just same idea as a list comprehension, except you need two expressions. One expression for the key, one expression for the value. Okay. And it's going to just be key expression, value expression, value expression for value in the collection if condition. So here I'm going to say, all right, here is a list of fruits, apple, mango, banana, cherry. And what we will do is we will capitalize it, and then this is going to be our expression for the key. This is pretty silly. And then we will have the value will be the length, that basically how many letters are in there. And so when we do that, we get a dictionary with apple has 5 letters, mango has 5 letters, banana has 6, and cherry has 6 letters. Here is a list of strings, and I could say enumerate them, okay? And so remember what enumerate does is it returns a list of tuples where basically we've zipped together the numbers, range 5, 0 through 5, or range, range 6, 0 through 6, along with the words in the original thing. So enumerate is another kind of handy little thing, and it just it zips together a range object with of the same length as your iterable here. And so here I can say, for each index value, we're going to unpack the tuples and enumerate the 0 and the A as index and value, and we can just say, hey, you know what, make a dictionary out of this, okay? And we get 0A, so on and so forth. Okay. I think I could have just as easily done dictionary on this, and we would have gotten the same thing, okay? But you can do something, a little bit more complicated. If you wanted to, you could do something. I can swap, right? So when you enumerate it, the first item is the index and the value, and as far as it getting unpacked and you create your dictionary, you can do however you want. So here I can unpack the enumerate as index and value and store it in my dictionary as value : index. So now my key is the word, and the value is index position. So this is basically the reverse dictionary, and we've got A colon, the key is A and the value is 0. The key is as and the value is 1. Okay. And so the index mapping, I can say, hey, where is A? If I ask where is A, that's not going to work because A is not one of the keys. So we would get an error here. Okay. I would need to ask like, hey, what is the corresponding, what is key 0? Okay. Location mapping, I can say, hey, where is A located? Okay, or what is the value associated with A? And it's going to give us back 0 here. Okay. If you want to kind of combine them together, we can use star quargs and take everything in location mapping, everything in the index mapping. Okay, these two dictionaries, unpack them, create a new dictionary, and we can do that. The better method though is to use dictionary.update. So I could take one of my dictionaries, location mapping, update it with additional entries, okay, and then now we will get the full thing. So we'll have both the name, the value along with its index, and kind of the reverse. If for whatever reason we wanted to keep all of these things together within one dictionary, it's possible in this way. So list comprehensions and dictionary comprehensions very kind of similar, right? And then another thing that goes right along with this is the generator, right? And a generator looks almost exactly the same as a list comprehension. The only difference here is that you use parentheses instead of square brackets. Okay, so notice over here we have we created a list comprehension using square bracket, x to the second power for x in range 1 through 11. Here I'm going to create a generator expression, and we're going to say n to the second power for n in range 12. Okay, but here this is in parentheses, and so what do we get here? This is not a list comprehension, this is a generator. Okay, and so now it says this is a generator object. And I can ask, okay, what is the value in G? So we keep calling next, and it's going to do the first thing, which will be 0, and it will return 0 squared. And then I ask, okay, what's the next value? And it's going to return 1 squared. And what's the next value? 2 squared, 4. What's the next value? 3 squared, 9. And then I could just kind of say, for each value in G, go ahead and print those out, and it will give me the rest, right? So 16 up through range 12 ends at 11, so I get 16, 25, so on and so forth. Okay, after it has run out of things in the generator expression, there's nothing left, right? So if I ask next G, it says nope, there's nothing. There's an error. It gives us the stop iteration. Okay, so that's a generator expression, and you feel like, what? This is nothing like a list comprehension. Okay, or if it feels very different from a list comprehension. However, they're actually pretty much the exact same thing. The only difference is that the generator is lazy, and it's not going to do anything until you ask it to do something. Whereas the list comprehension is not lazy, and it evaluates everything as soon as you create it. So here I'm going to create two things very, very similar. One is the list comprehension, and the other is the generator. Both are the same thing, right? So I got L square bracket, and basically we're just going to return 2 times n. Okay, so for n in range 1,000, and then over here I've got G for n in range 1,000. So both of these are going to start at 0, and then just return 2 times whatever n is. So if I say, hey, what is the type L, it's going to say it's a list, and what's the type G, it's going to say it's a generator, right? So L is a class list, no problem there. G is a class generator, okay? key difference, again, because the generator is lazy, it doesn't actually store any of this information. Yeah, question?
I was just wondering if there was like a back function for a generator, or like it just like deletes out of storage.
It just goes and then it's done. Yeah, it doesn't. If you want to store things, you got to store it, and if you want to go back, you got to. Yeah, there's no looking back. Yeah, for a generator. So generators, like as far as like memory and storage, it's more efficient, but you gotta have a plan when you're gonna employ a generator. Okay, so one thing is like for the list, it evaluates all of these things and it stores it all in memory. So it's about 80 times bigger than the generator. Okay, the generator is just basically a little piece of instructions that says do this. When you get to the next number, return 2 times n. Okay, and then the list says do this and write all of these things down. So it had to write all of this down. Okay, so with the list though, you can say because it's written everything down, you can ask, hey, what is the 5th item in the sequence, right? What is that index position for? And you can do L square bracket 4, and it will be able to do that, okay? With the generator, you can't subscript it. You can't say, hey, what is the 5th thing? Because the generator hasn't evaluated any of this, right? It's kind of like, I don't know. You know, if I ask you, hey, what is, like, what's the capital of the 15th state, right? You'd have to kind of like, if I give that to you now, you'd have to like think, and you go, okay, well, the first state, you know, if we're in alphabetical order, is what, Alabama and Alaska, and you have to kind of go through it, and you go, okay, what's the 15th state? I have no idea. And then you say, okay, what's that, right? Whereas if you have a list, then like, you know, you have to kind of pull this out of your pocket, and you'd say, oh, okay, the 15th state is this, and this is the capital. And so that's all on hand, but the downside of that is you have to kind of carry that information around with you, whereas with the generator, maybe it's all in your head, but you have to kind of like remember this, right? Like I could say, hey, what's the 15th letter of the alphabet? And you like, either you have it memorized, or you go, okay, A, B, C, D, E, F, G, and then you go through and you say, okay, the 15th letter is, and like O or something like that, right? And you kind of get to that answer that way. So so that's how it goes. Okay, both of these things you can kind of iterate through them. So with the list, you can say for item in the list, you know, print out the item. And here I'm going to just say, hey, if the item hits goes over 12, right? So we're doing, you know, n times 2. Quit the loop. Okay, so we're going to go through and we start off at 0, 2, 4, 6, 8, 10, 12, 14. And then so it prints out 14 and realizes, okay, that's now over 12, so then it quits. Okay, same thing over here. For the generator, we could say, hey, go through and do this, and it gives me the same results here. Okay, G here is still a generator object, so as soon as it stopped evaluating. Okay, so you say, hey, what's the 15th letter? It says the letter O, and then it stops thinking about it, right? So then you say, hey, what's the 23rd letter? It doesn't know, right? It doesn't think about this kind of thing. You could say, hey, give me the sum of everything left in the generator. Okay, when you do sum of G here, because it's already evaluated 0 through 14, it has no recollection, no memory of that, right? And it just kind of keeps going forward. It says, okay, starting here, we're going to go through the rest of the list, and it does that. Whereas if you say, hey, give me the sum of the list, again, it's got the list of everything, and so, you know, the sum here is going to be different. Now, you can say, all right, I want the sum from everything 8 on, and you'll get the same match here to get the equivalent sum as the generator here, okay? With the generator, once I call sum, it had to go through and evaluate everything in the entire generator. And so if I call sum on G again, it says there was nothing left to evaluate, the sum is now 0, right? So the generator only exists for basically like one run. And then once it evaluates it, it's gone, and it keeps kind of moving forward. So, and then where the other thing with the list, it always kind of stays and it's there. You can always ask the sum and it gives you back the full sum. And so, you might be like, why would I ever want to use a generator? It seems like way more complicated. It seems like a lot harder. And it's true. Lists are a lot like, lists feel more tangible, okay? Like they're there, I can reference it, I can kind of do all of these things. But again, sometimes you're in a situation where you have like a billion items or something like that, okay? And or the iterable that you have is really, really, really huge, and you only want to evaluate to some certain point, okay? Maybe like up to the 18th value or something, okay? But you don't actually know, is it the 18th or the 19th or the 20th? Because you want to keep evaluating until you reach some kind of threshold, right? And so if you say, hey, do a list comprehension, it's going to have to take all of those things and it's going to have to evaluate every single one of these things. And then it might go, oh, okay, all right, here we are and we're done. Whereas a generator, it will do the same kind of thing, but then again, you can evaluate whatever that item is, okay? So again, you might have a really big thing and then you might have some kind of expression which might be more complicated than n times 2, okay? But it evaluates that thing and it keeps going until it reaches some kind of threshold, and then it says, okay, I got my answer and now I can stop. Okay, I didn't have to do it for all 1 billion. Maybe I had to do it for the first 170,000 values, okay? And it had to kind of run through them. But at 170,000 values, you say, okay, I got the answer I needed, so now I can stop. And it stops. Whereas the list comprehension says, oh, I got 1 billion values. I've got to process all of this first, right? Obviously, if you're going to do something like, I want the sum of all of the numbers, okay, then just go ahead and do the list because you're going to have to evaluate the whole thing anyway. But as far as the generator goes, these are more useful in a situation where you do need to do something sequentially through the iterable, but maybe not for every single value. Okay, if you feel like, okay, I need to kind of run through each item one by one, but at some point I'm going to be able to stop, then I think a generator makes sense in that situation where you don't have to evaluate everything, right? So it's kind of like, I want to go through, I want to keep asking students, a question until we find a student, or until we find 5 students who fit some kind of criterion, okay? You don't have to then, like, if you just need like the first 5, all right, you can just kind of like survey a student, get a yes or no answer, keep going and going and going, and like, rather than having to send the survey out to like all of UCLA, okay, like however many, 30, 40,000 students there are, you could just say, okay, first we're going to start, it's kind of like, all right, let's start off with 100 students. You send out the generator's doing it one by one, but basically it's like, send out, did I get enough responses from like the first 100 that I surveyed? I did, and we can stop. I didn't, we surveyed a few more people and then we kind of do that. So that's the kind of the conceptual difference in as far as use cases for generators versus list comprehensions. Okay, let me go I've given you one view quiz answer. Okay, second answer today is the letter D. Okay, letter D. All right, we have, there's something called lambda functions, all right? So sometimes we're in situations where we want to like apply a function, okay? And there's something called map. And basically map will take a function and apply it to kind of everything in the iterable, okay? So the map takes a particular function, maps it to each element in the iterable. It returns what we call a map object, and that itself is iterable. So I'm going to do some regular expression stuff. I'm going to import the regular expression module. I didn't really cover regular expressions in this class, and so I'll just kind of keep the regular expressions very, very simple. Regular expressions are little tools that we can use for handling strings and character information. So we've had stuff like make something uppercase, make something lowercase, and those are all kind of built in to Python as far as strings go. We also have like, does it contain the letter A? And basically regular expressions kind of take all of that, but just extend it, and you can do some really powerful string manipulation and searching. And unfortunately, we didn't have time to kind of cover regular expressions in our course. If you take Stats 102A, at least with me, I cover regular expressions in my 102A class, but I elected not to include them as far as this goes. Okay, so here we're going to define a function called replace space, and what this will do is it will search for one or more space characters and replace it with a single space. Okay, so in like text files, we can put spaces using the space bar, but we can also put in spaces using tab, new lines. There's different kinds of white space characters. There's also like non-breaking white space characters, which act kind of funny. They basically act as like a letter in that the word is not going to break. It's not going to break across two lines if you use a non-breaking space character. But anyway, to the eye, it all looks the same. But what we're going to do is we're going to say, hey, if there's multiple of these space characters, just replace it with a single space. Okay. So here I got hello space 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 Alabama space, and what this will do is it will replace kind of all of these continuous spaces with a single space character, and it just gives us hello space Alabama, and then the single space over here is kept. Okay, I've got just a list of just some bizarre characters here. All right, so we have hello Alabama, Georgia exclamation, Georgia, just different spelling or different capitalizations of Georgia, Florida, capitalized funny, South Carolina with wonky characters and stuff like this. Okay, and what I'm going to do is I'm going to say run, I'm going to map this function replace space onto the text. And what this gives me back is it gives me a map object, right? So a lot of times when you ask for something in Python, we're expecting like a list to come back or something, but it gives you these, these objects like generator objects or some kind of thing, a zip object that doesn't actually do things. Because a lot of things in Python are, again, inherently lazy. Because Python, as far as its like computational efficiency goes, it's on the slower side versus say something like C++, where a lot of these things are optimized in memory to kind of operate very fast. Python's design philosophy was, let's make writing this stuff easier for the human, okay? And then, our evaluation may not be the fastest, but to kind of make up for that, we're also going to be lazy, right? When the human asks us to do something, we're only going to do it when we need to. Okay, and that's how I'm going to kind of speed up my computation time. Because if I compute everything out every single time, that's going to really slow things down. So it's going to say, hey, you want to do a map thing? Sure, I've got this, and I'll give it to you when you ask me for it. But I'm not going to go ahead and evaluate it, right? Because this list could be like 1 billion items long, and we don't actually want it to evaluate right now. Okay, but so here this acts very much like a generator. Okay, so I'm going to say G2 is this map thing, and we're going to say, okay, go ahead and give me the next thing in G2, and it runs, replace space on this, and it gives me that. Goes to the next thing. Here's Georgia, and so on and so forth. And so very much kind of like a generator, it goes. We have this map object, and it will give me the things when I ask for it. Okay, and if I say, hey, I want all of this put inside a list, then it will go ahead and do that, right? Okay, so here so if I didn't, so what I can do is I can take kind of our map thing and I can just iterate through it, and it will go through and it will evaluate all of this. Again, because it's like a generator, we can also just take that entire generator and put it inside a list, and it will go ahead and evaluate, right? So anytime you tell Python, make a list out of this generator object, it will say, okay, I hear what you want, and I will go ahead and generate all of these things, okay? But the default is it's going to be lazy, and it's going to just say, all right, I've got the instructions. Do you actually want these things? Okay. Now, here, in order to use map, I had to create this function called replace space, right? And in this case, my replace space function is very, very simple. It just says, run some regular expressions, substitute. Anytime you see one or more space characters, replace it, substitute with a single space character, okay? We can create something called a lambda function, all right? A lambda function is basically an unnamed function. If you don't want to go through and say, hey, you know what, this function is so simple, all it's going to do is it's going to take in our argument x, and it's going to just replace the spaces in here. I don't actually need to go through and define a function formally called replace space. And so here we can just say, hey, here's a function. And this is, again, look at, let me just kind of compare. All right, so here's the function here. The function that, as we wrote it, says, hey, take in the argument x, and then with x, take that, run the regular expression and return this thing, okay? With the lambda function, basically it's saying, okay, here is a function. We're not even going to bother naming the function, okay? But what is the argument that you're going to take in? The argument you're going to take in is x, okay, colon, and what is the thing that you're going to return? The expression that we're going to return is going to just be like take x, run the regular expression substitution, and replace any kind of spaces here, right? So this allows us to just speed up our code writing in that I don't have to define separate functions out here. It's not that, I mean, I don't know if I'm saving a ton of time, but it is like, it is a technique that is used frequently within Python, is this idea of like, I just need to kind of create a function on the fly. I don't really feel like formally defining it, and we call these things lambda functions, okay? So here's another lambda function. What is this going to do? It's going to take the string and basically turn it into title capitalization form, which takes the first character and capitalizes it, lowercases everything else. If there's a space, it's going to capitalize it, and so on and so forth. So here I'm going to say, all right, map that unnamed function to the text and make a list out of it, okay? And so here we've got hello Alabama, and then it takes all of our funny capitalizations of Georgia and Florida and South Carolina, and it does there, okay? Yeah, question?
So whether you use X or a string doesn't matter. Is it just like a iterable variable?
It is just some argument. So it doesn't even have to be iterable, okay? The thing that needs to be iterable is when you use map, okay? Map is being applied to some kind of iterable thing. So here I've got the, as far as text goes, text is this list. So map takes the function and it applies it to every element in the thing, okay? And it returns a generator, basically, a generator-like object, okay? And in our case, we're just saying, I want everything, so I'm taking the result of map and putting it inside a list. And that's gonna go ahead and run through the entire thing. But this thing, again, whatever I wanna name the argument here, I could call it y, and then, you know, what do I want? I want y.title, okay? And, you know, further, I could kind of further combine it with this. I could say, all right, go ahead, and what we actually want to return is substitute. Here, actually, let me, like if I want to, I could make my my function more complicated, right? I could do string.title, and we can substitute the more than one space character with a single space character, and we're going to apply it to that. And now we're kind of running this. So here I've got kind of like the function that I'm running is even more complicated. All right, I'm basically doing two operations. I'm taking our original text, or within the text, I'm taking each string, I'm making a title case, and then upon that title case, I'm substituting spaces, multiple spaces with a single space, and it you know, kind of runs these things here. And you can do that. At some point, you know, your Lambda function might get so complicated that it's hard to read, and in that case, probably define the function separately. Okay. But again, if it's a simple enough function, and there's no real limit on how complicated your function has to be or it can be, it's just it's for your own kind of benefit. You know, is your function simple enough that you can just kind of encapsulate it in one line without having to define something, you know, on the outside. Okay. And so again, you know, as far as your functions go, you can have functions with multiple arguments. You can have a function that takes in an x argument and a y argument, and returns that. So here I've got this function is going to take x and y and add them together. And in that case, if we're going to run map on this, we need to provide basically a list of x values and a list of y values, and we can do that, right? And so here I'm going to we need a list or an iterable for the x argument, a list or an iterable for the y argument. Okay, and again, this is going to apply for any kind of iterable. So I can do ABC, and we can do XYZ. Okay, and this will work as well. Okay, because it just takes the two iterables and it says I want to do A plus X, right? And as far as text goes, you know, treating this as an iterable. So so that's going to work as well. These are this is how we use map. So it's kind of like apply. In R, you guys covered the apply functions and lapply. It's a lot like that again, but this is lazy. So it creates a generator, right? So if I didn't have this list thing, it's going to create something that looks like this, and then we would have to take this object, and then I would call next on it, or put it through some kind of iterable, like a for loop, or something. Or I could say, hey, evaluate everything by putting it inside a list. Okay, and that's that. Okay, let me go ahead and give you your last view quiz answer. Question 3 is B. What did I say? Question 2 is D. Yep, question 3 is B. Okay, and that will be it for today. So that covers our Python features. I'm planning on the next thing I'm going to do is I'm going to look at, I'll introduce like SQL, just because that's kind of like a useful thing. We're going to just look at some very basics of SQL. So we'll take a look at that on Wednesday. Okay, but this is it for Python stuff. And yeah, we'll see you guys on Wednesday.